One of the glories of the Industrial Revolution, for which we should all get down on our knees and give thanks, was that people went from wearing this to this. In the 19th century, we will be mostly wearing cotton undergarments. Cotton wasn't just more comfortable, it was healthier too. Nobody bothered washing their heavy woolens much, so as well as being extremely itchy, they were also filthy. No wonder that dysentery and scabies were endemic. But the reason cotton became the thing to wear wasn't because of some new hygiene obsession. It was because all of a sudden, cotton was cheap. And that was a revolution. So how did cotton become so affordable? What changed it from a material imported from overseas for the few to something made in vast quantities here in Britain for the many? Cotton, much more difficult to spin than wool, has a short staple length, the length of each fibre. However, here goes. Cotton has been spun in the same way for 1,000 years, using this, the drop spindle. Just put a hitch there, and this is my carded cotton. So, by using the weight of the wood, we draw the fibre out, and then the spinner gives a twist, locking the fibres together. But if you spin too early, you go too thick. And if you spin too late, it goes too thin. It's too thin. So it is a skill that I have not mastered. The spinning wheel increased spinners' output, but it wasn't until 1764, when Lancastrian James Hargreaves had a brainwave, that spinners could really step up production. His invention was the spinning jenny. The spinning jenny worked on the same principle as the spinning wheel. Here we have the rovings, the unspun cotton, and that's thread on there, and this is how we get it. By pulling back, we pull off the bobbin here, okay? And then we trap it between those two pieces of wood there. So this now is stationary. This spindle at the end is connected to all the other ones, which are connected to this wheel. And as we wind this wheel, it's quite a knack this, but you'll see it comes off the spindle like that, and as it flicks off the top, it's putting a spin into the roving. And because the rest of it's stationary, it's clamped here, and this isn't moving, it's spinning. Okay. And we've now got spun thread between here and there. So this is the complicated bit. What we have to do is go backwards a bit and take that off, and then put the guide wire down like that, and then moving forward quickly the other way, we wind it on. Bingo. Mechanically simple, economically breathtakingly sophisticated, because what happened was that 120 spindle machine, this is a 30 spindle machine, on 4 draws, that's backwards and forwards 4 times, could spin half a mile of cotton. So in the old days, 6 spinners would work to supply 1 weaver. Now, 1 man spinning on this could supply 8 weavers. Cash. The jenny took cotton out of the home and into the workshops, sounding the death knell for spinning as a cottage industry. Other traditional cottage industries, such as weaving and stocking knitting, were becoming mechanised in the same way as spinning. One traveller to the north wrote, "Every rural sound is sunk
in the clamour of cotton works, and the simple peasant is turned into the impudent mechanic. But not all impudent mechanics were happy with the changing ways. Men who were at ease with the way that they worked in their cottage industries thought that mechanisation would destroy their livelihoods. Nervous of the future, they smashed the new machines and rioted, and people died. So, if you wanted to make a profit from this new technology, you had to protect your investment.
And this place took it very seriously. Huge studded door, locks based on those at Derby Jail, produced to order by a London locksmith, and these. Gun embrasures. All for a cotton mill. William Strutt built this factory in 1803 on the site of the previous one, which had burnt down, but he wasn't going to let that happen again. Built of stone and cast iron, this is one of a new breed of fireproof mills, and with its metal frame construction, it is revolutionary. In fact, it's the grandfather of the skyscraper. But why this obsession with defence? Why build gun embrasures? He felt that he needed the protection of firearms because he had something in this mill much more impressive and much more advanced than the Jenny, and it was putting spinners out of work.
What he had was a machine invented 30 years earlier by his father's partner, Richard Arkwright, a wig maker from Lancashire. Strutt needed cheap yarn for his hosiery business, and Arkwright had come up with an invention that would provide him with more than enough. But fearing the wrath of Lancashire spinners, Arkwright had looked elsewhere to develop his machine. Security wasn't the only reason for the move. Arkwright knew that Hargreaves had hardly made a penny from his spinning invention. Unscrupulous businessmen had stolen his idea and just made their own. Arkwright knew that his idea was good, and he was determined that it was going to make him a fortune. Good lad. So, in 1771, he moved here, to Cromford, a tiny mining village on the south side of the Peak District. No one would steal his new invention here. Cromford was to become Britain's spin city. Cotton was becoming the fashion fabric. After all, why wear this when you can wear this? Actually, I prefer the sweater, but I'm making a point. Beautiful patterned cotton from India was all the rage. And Lancastrian barber and wig maker Richard Arkwright had come up with an invention that was going to revolutionise the cotton industry. To keep his machine a secret so that he could make his fortune, he set up shop miles from traditional centres of cotton production, here in leafy Cromford in Derbyshire. And this is his invention. This is an original of 1803, so can't be used. But this is a replica with 4 spindles instead of 48. As you can see, it's quite a simple machine. Turning the belt drive draws the yarn through the 3 sets of rollers, rotating at different speeds determined by the gearing mechanism. The weights put the stretching yarn under different degrees of tension. The second roller runs at twice the speed of the first roller, stretching the yarn to twice its length. Then the third roller runs at twice the speed again, so doubling the length of the cotton again. Finally, the spinning spindle puts the twist in the yarn. It's quite a beautiful action. Through trial and error, Arkwright worked out the critical distance between rollers. The length of cotton staple being only 2.5 centimetres, any less than that and the fibres would break.
longer than 7 centimetres and it would be too weak. Maybe years of curling wigs gave him the idea. The rollers, the top being leather covered and the bottom metal and splined, gave the right amount of friction, and the front weights stopped the yarn twisting before it had been stretched. There's no great leap in technology here. This is the logical application of current knowledge. This replica was built by a local clockmaker, and in fact Arkwright advertised for clockmakers to make his machines. These cogs here look just like the innards of a timepiece. So how good was this machine? Records suggest that to process 100 pounds of cotton would take Indian hand spinners 50,000 operative hours. Yet the same amount could be processed in only 300 hours using Arkwright's machine. And because Arkwright's spinning frame was designed to be powered by water, operators didn't need to work the machine anymore, they simply had to maintain it, changing threads, oiling moving parts and the like. And any woman or child could do that.
Cotton could now be spun in mills on Arkwright's frames, using cheap, unskilled labour and the latest water-powered technology.
In 1751, some real scientific research was undertaken into the efficiency of water wheels by an instrument maker by the name of John Smeaton. He made 60 centimetre models of wheels and found that the overshot wheel, where the water runs onto the top of the wheel, was 65% efficient, compared with 25% for an undershot wheel, so that the judicious use of gravity gave a 40% increase in efficiency.
And this is an overshot wheel, as opposed to a pitchback, high breast, low breast, undershot, impulse or stream wheel. Those classifications, of course, applying only to the Vitruvian wheel as opposed to the Norse wheel. So, the water wheel drives this cog, which connects to the smaller cog on the end of this shaft, which connects to this belt, which runs this high axle up here, connected to another belt, which works machinery. Arkwright's first mill at Cromford was powered by a single overshot wheel driving spinning machines across 6 floors. In its day, there was nothing like it. Today, it's a building site, but you can still make out where the water wheel went. There's a more recent launder following the path of the original, which carried water from the river over the road. To get an idea of the kind of water power required to drive a mill like Cromford, we have to go to Masson Mill, another Arkwright mill built around the corner from Cromford just a few years later.
You can still see the weir and the leat, and it gives you some idea of the power of the water and the energy it created.
When the sluice gate is lifted, the leat drains, providing the mill with a huge head of water.
And it demolishes forever the cliché of the ramshackle water wheel on the tiny rural stream.
Water power, cheap labour, and the water frame now allowed cheap cotton. It had made Arkwright an extremely wealthy man and turned spinners into factory employees.
Arkwright's water frame was so large that spinning yarn at home was no longer an option. Instead, Cromford, like this later Arkwright mill, was built just wide enough for 2 water frames end to end. In this room, that's 48 frames, a total of 2,304 spindles. And that is not just a change in scale, that is a change in which the whole industry is organised. Arkwright, paranoid that his invention might be stolen, worked the mill 120 hours a week to get as much money as possible out of it. And the people who worked in this mill couldn't stop and start, come and go as they pleased, as they used to when they worked from home. They were now factory employees, and they worked when Arkwright told them. Just imagine the noise.
Arkwright was the prototype ruthless mill owner. These are his workers' houses. He invented most of the oppressive working practices we now associate with the bad old days. Making women and children work from 6 in the morning until 7 at night for a pittance. And once a year, he made his workers sing his song. Let us all here join as one and give him thanks for favours done. Let's thank him for all favours still that he hath done beside the mill. Modestly drink liquor about, and see whose health you can find out. This will I choose above the rest. Sir Richard Arkwright is the best. Was he really? It better have been a good tune. But the very isolation that drew Arkwright to Cromford was causing problems. This wasn't the wool industry with raw material in every field. He had to get imported raw cotton from London and Liverpool. So, along with other local businesses, Arkwright petitioned to have this built, the Cromford Canal. Completed in 1794 by William Jessup, John Smeaton's assistant. Remember him? It was 14.5 miles long and stretched from the Erewash Canal to here, just yards short of the Cromford Mills. Now cotton shipments were off the potholed roads, and on the canal network they could get in and out of the valley much more quickly and cheaply. It was called Arkwright's Canal, but the irony was he died 2 years before it was completed. And it wasn't enough. They still needed more routes out of the valley. Not just anywhere, but to Lancashire, where weaving mills were crying out for cheap yarn. So, Jessup's son Josias kept it in the family and came up with something new. This, the Cromford and High Peak Railway. The Peak Forest Canal was the other side of the Peak District and ran to Manchester. It was suggested that a canal was built to connect the Peak Forest to the Cromford Canal. But because of the massive gradients, it's 300 metres from the junction down there to the summit up there, it proved impossible. Instead, they laid rails, but they treated the route as if it was a canal. Long, flat sections interspersed with short, steep inclines, sometimes up to 1 in 7. The new railway reinforced Cromford's importance as an industrial centre. Cheap cotton could now be sent to the weaving mills of Lancashire. These original Cromford and High Peak Railway Company rails are cast iron and 1.2 metres in length. They are all straight, so curves are just composed of these straight sections. That made the 33-mile, 5-hour journey a bit of a bone shaker. There are also no sleepers. These rails are laid on stone sets because the flat sections were horse-drawn. Therefore, the horses could walk between the rails. But when things got this steep, the High Peak used a stationary engine to haul the wagons like a vast ski lift. And you don't build engines like this just for a laugh. This magnificent beast is one of 9 that used to haul the wagons up the various inclined planes. I want one. This is an early Butterley engine, 1829. Simple, solid, and it does the job. Made in Derbyshire. It's a development of the Newcomen atmospheric pumping engines, only this has a closed cylinder. So steam expands one side of the piston and condenses the other. So you have a powered up motion and a powered down motion, as opposed to the old atmospheric engines where you only had a powered up motion. So if you can translate this powered up and down motion into a rotary action, you can not only pump, you could drive machinery. Both ends of the beam move in an arc. But you have to find a way of allowing the piston rod here to retain its vertical motion so that it's perpendicular to the piston. Otherwise it wouldn't be steam tight. James Watt came up with the answer: the parallel linkage. A very elegant solution to the problem, of which he was justifiably proud. So now you can attach a sweep arm to this end of the beam, which will drive a wheel. That kind of thing. That's it. The piston rod moved a 5-metre beam via parallel motion, driving a flywheel 5 metres in diameter at 40 revs per minute. On either side of that flywheel are these two wheels, 4.5 metres in diameter. A rope ran round them all the way to the bottom of the incline and then back up again in a continuous loop. It ran until 1967, hauling its own coal up the incline to fire its boilers. Cotton was the first industry to be revolutionised. Water power produced vast amounts of cotton, and it's no wonder that the place Arkwright chose to site his mill was to be a big player in the industry. And soon, Cromford had its own canal and railway routes. Next time, I'll be looking at how a local trade became an international industry.
Right, let's try again. Start again. Start again. I'm just making a mess, and I haven't got the job.